Welcome. You have just been handed access to a file most people will never open. A world sits 41 light years away, quietly orbiting inside the zone where life is possible. This is not a casual observation. We are examining a world named after a man history nearly forgot. Thomas Harriot drew the moon before Galileo ever pointed a telescope upward. Harriot was an English astronomer, mathematician, and ethnographer. He sketched the lunar surface at the end of the first decade of the 16th century, months before Galileo's famous drawings appeared. Science remembers the loudest voice, not always the first hand. In December 2015, the International Astronomical Union made it official. The IU's Name ExoWorlds project assigned his name to this distant world. A forgotten pioneer finally received a planet as his monument. The planet's scientific designation is 55 Cancri F. That single letter, F, carries significant weight in astronomy. Harriot was the first exoplanet ever designated with the letter F in any system. Its discovery has an unusual origin. Jack Wisdom did not find it through fresh observations. He detected it by reanalyzing data that other scientists had already published and then moved past. That is forensic science at its finest. The evidence was already on the table, untouched, overlooked, and waiting. Wisdom read what others had written without fully understanding what they had found. The initial announcement came in April 2005, but peer-reviewed publication did not follow until November 2007. 2 full years passed before the scientific community formally accepted this world into the record books. Meanwhile, the planet kept orbiting, indifferent to human paperwork and academic timelines. It completed roughly 3 full orbits around Copernicus, while scientists debated whether it deserved to be officially written down. Its home star is called Copernicus, formally designated 55 Cancri. It sits 41 light years away in the constellation Cancer. On a clear dark night, you can find it without a telescope. Copernicus is a G-type yellow dwarf, remarkably similar to our own Sun. But it is older, estimated between 7.4 and 8.7 billion years old. It has been burning far longer than ours. Our Sun is approximately 4.6 billion years old. Copernicus has been fusing hydrogen for nearly twice that duration. Whatever orbits, it has had extraordinary amounts of time to develop into something significant. Copernicus is not alone in space. A faint red dwarf companion orbits it from billions of miles away. These 2 stars have kept each other company across the entire history of complex life on Earth. From a moon orbiting Harriot, that red dwarf would not be invisible. It would be a prominent, bright object hanging in the alien night sky. A second sun, dim but undeniably present. The 55 Cancri system holds 5 confirmed planets. When Harriot was discovered, it made history immediately. This was the first star beyond our Sun confirmed to host at least 5 orbiting worlds. The inner planets are named Janssen, Galileo, and Brahe. They orbit ferociously close to Copernicus, completing full years in just a few days. These worlds bake in radiation at Mercury-like distances. Then there is Lippershey, the massive outer giant of the system. It takes over 14 years to complete a single orbit. One Lippershey year spans nearly 4 full human presidential terms. Harriot sits between these two extremes. It orbits at 0.781 astronomical unit from Copernicus, comparable to Venus's distance from our Sun. It is neither roasting close nor freezing far from its star. One full orbit takes approximately 260 days. That is Harriot's year, shorter than Earth's, but longer than Venus's. It moves through space at a pace that feels almost familiar by solar system standards. Its orbital shape sparked significant scientific debate. Early models suggested a moderately elliptical path, but complex Newtonian gravitational models, accounting for all 5 planets, indicate its orbit is nearly perfectly circular instead. A circular orbit is not a small detail. It speaks to gravitational stability across billions of years. Harriot has been tracing the same smooth path around Copernicus since before Earth had complex life. Scientists suspect all 5 planets orbit in the same flat plane. This coplanar arrangement mirrors our own solar system's architecture. It suggests a shared origin, a single spinning disk of gas and dust. That original disk collapsed, clumped, and slowly built worlds over millions of years. Harriot emerged from that same ancient material. It is a relic of planetary formation, preserved in near-circular orbital amber. Now consider its mass. Harriot weighs approximately 45.78 times the mass of Earth. That is roughly half of Saturn's total mass, substantial, but not overwhelming by gas giant standards in this system. Because it was detected through radial velocity, we only know its minimum mass. The true orbital inclination remains unknown to us. If the system is tilted, Harriot could be 25% heavier still. Hubble Space Telescope astrometric data offered a partial clue. The outer planet Lippershey showed measurable orbital tilt. If the whole system shares that alignment, Harriot's true mass reaches roughly 0.18 Jupiter masses. Its physical radius has never been measured. Its atmospheric composition remains completely unknown. Harriot was never captured crossing its star's face, so no transit data exists to reveal its true dimensions. What scientists have done is model its likely appearance. Based on estimated temperature ranges, Harriot may be a Sudarsky Class II planet. That classification means its atmosphere would be dominated by thick water cloud decks. Imagine vast rolling oceans of clouds, not liquid, not solid, but suspended vapor pressing against itself under enormous atmospheric pressure. Harriot may wear this permanent white shroud across its entire upper atmosphere. Surface temperatures, if a solid surface existed, could range from -73 to +27 degrees Celsius. That range spans frigid tundra to mild spring afternoon. The variation depends entirely on atmospheric conditions. Here is where the investigation deepens considerably. Harriot orbits entirely within the classical habitable zone of Copernicus. It was the first exoplanet ever discovered, spending its complete orbit inside that critical boundary. The habitable zone is not a guarantee of life. It is simply the orbital band where liquid water could theoretically exist. Harriot sits inside that band for every single day of its 260-day year. But Harriot itself is a gas giant. No solid surface means no standing ocean, no shoreline, no ground for anything to crawl across. Life as we understand it has nowhere to grip here. So scientists shifted their attention slightly outward, to moons. Large hypothetical moons orbiting Harriot could possess solid surfaces. They would sit inside the habitable zone, warmed by both Copernicus and Harriot's gravity. A moon that would experience tidal heating, friction generated deep inside its rock by Harriot's gravitational pull. That internal warmth could maintain liquid water even without perfect sunlight conditions from Copernicus alone. And time. Consider the extraordinary amount of time available here. Copernicus is at least 7.4 billion years old. Life on Earth took roughly 3.8 billion years to move from single cells to complexity. Now the definitive answer this investigation has been building toward. Harriot is a gas giant of approximately 45.78 Earth masses, orbiting Copernicus every 260 days at 0.781 astronomical unit from its star. It was discovered by Jack Wisdom through reanalysis of existing radial velocity data, announced in April 2005, published in November 2007. Its orbit is nearly circular, confirmed through complex Newtonian gravitational modeling. Most significantly, Harriot was the first exoplanet confirmed orbiting entirely within a star's habitable zone. Its hypothetical moons remain the most compelling targets for liquid water beyond our solar system at 41 light-years. If this investigation kept something alive inside you tonight, that feeling has a name. It is called scientific wonder. A forgotten astronomer now orbits a distant star as a gas giant. Subscribe to the Sleep Lab for more stories like this, and like, comment, and share.